I'm just going to break each of these down. None of these are perfect square, perfect cube, perfect fourth. They're all something that's going to have something left under the radical. Now, tons of different ways to do a factor tree. Somebody tell me, just tell me two numbers. If you know, you multiply them together, you get 45. 9 and 5. Okay. Now, tell me two numbers that multiply to get you 9. Okay. Now, 5, you could break down 5 to 5 and 1, I guess, but that's not going to be helpful to you. So you broke down the 45, you broke down the 9. If you're working with the square root, to take anything out of the square root, you're looking for a pair. So I have a pair of 3s, so that comes outside. And anybody that does not have a partner under a square root, the 5, he's alone, so he has to stay under the square root. So that would simplify to be 3 roots of 5. Anybody have a question? Okay. Now, that's for square roots. You're working with partners. You guys have done this forever. These ones you probably have not done. If you're working with a cube root, to pull something out, you need a group of 3 of the same number. And I got another one up here. It's a 4th root. We're going to look for a group of 4 of the same number. But you can do the factor tree the same way. So I have a cube root, 250. If you look at this beautiful little list of perfect cubes, you're not going to see 250 anywhere on that, so it's not going to be perfect. So tell me two numbers when you multiply them you could get 250 out of. Perfect. Okay, 25 and 10. 5 and 5. 5 and 2. Awesome. Okay, broke the 250, the 25, and the 10. Now, this is a cube root, so I'm looking for a group of 3. So do you guys see it? We have 1, 2, 3, 5s. So if you have a group of 3, that comes out in front. And then this 2, nobody to hang out with, so it has to stay under the cube root. So we'd have 5, and then try and remember, I always forget this, but try and remember to write the index. So it'd be 5 times the cube root of 2. That would be the simplified version of that. All right, now the last one, this is a 4th root, so if I want to take anything out, I have to have a group of 4. Two numbers that multiply to get you 48. Okay, 8. There's like you could do 2 and 24. There's a bunch of different options. You could do 16 and 3. There's a lot of different options, but let's say we did 8 and 6. So then we got 4 and 2, 2 and 2. 6 would break down to be 3 and 2. So I broke the 8, I broke the 6, I broke the 4. I'm looking for a group for a 4th root, 4. So you got 4 2s. You don't have to go back and circle them. I'm just trying to color it a little bit to help. So the 3, no one to hang out with, so it has to stay under the 4th root. So this would be 2 4th roots of 3. Try to remember to write the index. I always forget. Okay. I am going to stop there. So there are situations where you would have some variable left under the radical. There's a couple ways to do this, and then just remember, if you have a square root, they don't write the little index in there, but it's 2. So to have a perfect square, my exponent has to be divisible by 2, right? So 3 not divisible by 2. Okay, so what I would do, I'm going to try and use my exponent properties that we talked about the other day. I'm going to break apart x to the 3rd. I'm just going to do 2 pieces. I need my exponent to be divisible by 2 to remove any perfect squares. Now I've only got 3, so I'm going to rewrite this as x squared times, it would be x to the 1st, but I'm just going to write x. Like if I put that back together, that would be x cubed. My goal, if I'm working with the square root, I want my exponent to be divisible by 2. So if I've got x squared, you're going to, and you don't have to write that in there, but you just divide the exponent by the index of the root. So that's a perfect square. That comes out as x. And then this other x is like 1 left over, is underneath the square root. Now, if you want, I'll do, the other thing you could actually do is take and if you would divide that exponent by the root, this would go in 1 time, right? 1 times 2 would be 2, and 1 would be your remainder. I know that's a little bit weird. So I'm going to pull out 1x, and there's 1x left underneath, if that makes sense. You could do it like that too. Just divide the exponent by the index of the root. So if you want to break it apart, if I have x to the 9th, I need something divisible by 2. So biggest thing that could add up with 9 to be divisible by 2, if it was me doing the problem, I would rewrite this as x to the 8th times x. Anything with an even exponent under square root is going to be a perfect square. So x to the 8th, divide the exponent by the root, that would come out as x to the 4th. Yep. And then you just have that x left underneath. If you prefer that division, like I just did a little long division, I divided the index 2 into 9. 2 goes into 9 4 times. 4 times 2 is 8. Remainder would be 1 if you're looking at that. I pulled out x to the 4th, and I had 1 x left underneath, if you like that better. It's totally up to you. All right. If you're working with a cube root, you need the exponent to be divisible by 3. So if I was going to break this apart, I would write, let's see, x to the 3rd times x squared. If the exponent's divisible by the root, it's perfect cube, so I'm going to remove this. This would come out as just x to the 1st, and then you would have, and I always forget this, but try if you're working with a cube root or a 4th root or whatever, try not to forget to write the little index in there, and you'd have an x squared left underneath. Okay, if you don't want to break it apart, if you want to divide, we would divide 3 into 5. So that would go 1 time. 1 times 3 is 3. Subtract that. The remainder is 2. So you see I pulled 1x out in front, and then there was x squared left underneath. Do you guys have a preference? Do you want to break it apart, or you want to do the division, or it doesn't matter? Break it apart? Honestly, I like to break it apart. I think it's a little bit faster. You got to think about it for a second, though. So this x to the 16th. So if I'm trying to get something divisible by 3, how would you break apart 16? 15 and 1, exactly. So 15 is divisible by 3. That's going to be your perfect cube. And then you just have 1x left underneath. This would come out as x to the 5th, and then left under your cube root, you'd have an x. If you're working the next group, these two have x to the 4th. So I need my exponent to be divisible by 4. So if I have 11 to work with, what number could 4 go into? 8. Yeah. So just break that apart, 8 and 3. Now, x to the 8th is a perfect 4th root because that exponent's divisible by 4. This would be x squared, and then left under your 4th root would be x cubed. As long as your exponent, like this is a 3 is my exponent, and my index is 4, if the exponent is smaller than the index, then you should be good. If the exponent is bigger than the index, then you could break it down farther. If you wanted it divisible by 4 and you had x to the 15th, 12 and 3, yeah. 12 is divisible by 4. 12 plus 3 would put that back together to be x to the 15th. So I'm just breaking it apart. The perfect square is going to have the exponent divisible by 4. That would come out as x cubed, and then left under that 4th root would also be x cubed, actually. And then if you got a 5th root, you just want your exponent to be divisible by 5. So if you're working with 12, 10 and 2, yeah. And so this would come out. Divide the exponent by the root to get your removal here. This will be x squared on the outside, and then we would actually have an x squared also left underneath that 5th root. How would you break apart 24? 20 and 4. All right, so 20. 5th root of that, just divide 20 by 5, so that could come out as x to the 4th. And then left under your 5th root would also be x to the 4th. Is anybody having a question? Okay, we're just gonna skip these two problems here, and because I want to do a factor tree instead, because that seemed to be easier for everybody. So let's just not worry about these two. We'll just do the ones on the back. Okay, so I've got these broken up. There's 2 square roots, 2 cube roots, and 2 4th roots. And So totally up to you how you want to do this, but this is going to kind of put together breaking down the number and then breaking down the variable under a radical in the same problem. These, I'm not going to lie to you, some of these answers like look super garbagey. So you're not doing something wrong. We're just trying to remove any perfect, in this example, squares that we can. Okay, so let's just do the number first. Let's just not worry about the variables for a second. Tell me two numbers that multiply to give you 50. 25 and 2, 10 and 5, there's different examples. I'll just do 25 and 2. Okay, two numbers multiply give you 25. 5 and 5. Okay, if we're working with a square root, which I do have here, we're looking for a pair, right? So we have a pair of 5s, and I broke down the 50 and the 25, so I'm not looking at those, but I have that 2 left underneath. So just with the numbers, we're going to have a 5 out in front, and then I'm going to do a 2 with the numbers. Then let me deal with the variables. If you're working with the square root, I got to have my exponent divisible by 2. So if I've got a to the 11th, I would just do 10 and 1. I just need, I don't know why I put an X there. So I'm going to do a to the 10th and then a to the 1st. Would you change b to the 4th? No, that's actually already a perfect square because that exponent's even. Anytime you have an even exponent, it's automatically a perfect square. All right, so with the variables, a to the 10th, we're going to pull out a to the 5th and b to the 4th. Just exponent divided by the index of the root. If it's a square root, you're going to divide by 2. That would come out as b squared. Now, left underneath, I still have a 2 and I have an a. So my answer, anything you pull out in front, everything just gets multiplied together. So 5a to the 5th, b squared, and then left under your square root, a 2 and an a. And it's just not a perfect square, so we have to have stuff left underneath. All right, you guys try the one next to this. See if you could break down the 32. All right, bad question. Let me go through this with you guys real quick. Okay, did most of you guys, it looks like, did 8 and 4 here? All right, I should have gone over. This one's kind of tricky. All right, so 8 would be 4 and 2, 2 and 2 if you kept going. 4 would be, let's see, 2 and 2. So this tree can get kind of tricky because it's got a lot of numbers on it. All right, so I broke all these down. Here's what you have. I have a pair of 2s, and I also have another pair of 2s. So if you have the same, or it doesn't matter if it's the same, but if you have 2 pairs, when you pull that number out, you multiply it. So I would take a 2 out, another 2 out, so then that would come out as a 4. If you take 2 different numbers out, you multiply them together. This 2 He is alone. He had no partner, so that would stay underneath. And so we'd have a 2 there. Now, did anybody break apart either of those? No, these both have even exponents. So all we have to do is divide the exponent by 2. That'd come out as x to the 12th, and that would just come out as a plain y. So then we'd have 4x12y on the outside. You would still have a 2 left underneath because 32 wasn't a perfect square. But both of those variables were perfect squares. It's just going to depend on the question. Does anybody have a question? Okay, now, these guys, when we're working with the numbers here, don't forget, if you're working with the cube root, I need a group of 3. So if you're working with the square root, you need partners to take a number out. If you're working with a cube root, you need a group of 3. Tell me 2 numbers that'll multiply to get you 24. 6 and 4, don't worry about the negative. Okay, 6 would be 3 and 2. 4 would be 2 and 2. Okay, I'm going to remember the negative, but I'm not going to worry about that when I do the factor tree. Okay, you're looking for a group of 3, which you got, right? 1, 2, 3, 2s. 1, 2, 3. And then the 3 doesn't have anybody to hang out with, so it has to stay under the cube root. The only thing I would tell you, if you've got a negative under a cube root, you can do that. When I take the 2 out, just write -2. That's literally it. If you got a negative under a cube root, just make whatever you pull out negative. Now, left underneath, I have a 3. And then x to the 4th, that's not a perfect cube, so let me break that apart. I would just write that as x to the 3rd times x, right? I'm looking for an exponent that's divisible by 3. That would be the only thing I could do there to get an exponent divisible by 3. The only other thing I can take out, 3 divided by 3, that's just going to pull out as a plain x. So -2 takes care of the negative x. And then try not to forget, I always do it on the cube root and the 4th root, but the index should be 3, and then you got 3x left under the cube root. All right. Tell me 2 numbers multiply to get you 54. 9 and 6, perfect example. If you ever get stuck, like if it's an even number, just divide it by 2 and go from there. There's different ways to do these trees. All right, so 9 is 3 and 3. 6 is 3 and 2. So we're looking for a group of 3, so I got it right there, right? You don't have to highlight it or anything. I'm just doing it on my paper. So I have a group of 3s, and I have this 1, 2. So I'm just breaking down the number for the moment. So I'd have a 3 out in front, cube root, 2 stuck underneath. Now, my exponents, if I'm working with a cube root, I want it divisible by 3. So if I'm working with 7 and 11, neither divisible by 3. So how can I break apart a to the 7th? 6 and 1. And how'd you break apart 11? Bless you. 9 and 2. Does that sound good? 9 and 2 add back up to be 11. All right. So you just have to make sure the exponents, that's your exponent properties we were reviewing a few days ago, but the exponents have to add back up to what you started out with. The goal is just to kind of break them up so you can get an exponent that's divisible by your root. Here I'm trying to get something that's divisible by 3. So I'm looking for like 3, 6, 9, 12 numbers that are divisible by 3. Okay, so let's see what we can take out. A to the 6 would come out as a squared, just dividing 6 by 3. 9 would come out as, b to the 3rd. And then the 2 that you broke to the side, those are going to be what's stuck left underneath, because those are going to add up to give us the original, but we're just trying to remove the perfect cubes. Anything that's already out in front, we're just going to multiply together. So we had a 3, a squared, b cubed, and then left under our cube root, we have fail at life. Okay, sorry. 3a squared, b cubed, and then left under the cube root, I have a 2, an a, and a b squared. Sorry, that one's like super garbagey, because the number was not a perfect cube, and neither were either of the variables in that one. What? Okay, I got one more. These are all 4th roots on the bottom of this. Okay, so if you're working with the plain number that's underneath, not the exponents, the plain number, you're looking for a group of 4 on your factor tree to remove anything. Anybody know 2 things multiply together to give you 162? Not super common, right? So if it's an even number, like it ends in a 2, right? I'm just gonna, I know it's gotta be divisible. I don't think it's 9 and 18 we could use. I'm gonna just use 2 and 81, if that's okay. If it's ever an even number, it's gotta be divisible by 2, so you can always start there if you're not sure. All right, so I'm gonna use 2 and 81. Tell me two numbers multiply and give you 81. 9 and 9. Now, if I was working with a square root, I would stop right there because I got a pair. But we're working with a fourth root, so I'm looking for a group of 4. 9, 3 and 3. Other 9, also 3 and 3. So I broke everything down except this 2 that's left up here. So I have a group of 4. That's what I'm looking for. So 1, 2, 3, 4. So we're going to take 3 out in front. Left under the fourth root, just for the number, would be a 2. All right, now, x to the 13, not divisible by 4, so I'm going to break it apart so it's divisible by 4. So I would do 12 and 1. That would add back up to 13, but 12 is divisible by 4, so I can remove something with the x. Would you change the y? If it was, no, 36 is divisible by 4, so just leave that alone. You don't have to break that apart. It's divisible by the index. So x12, going to come out as x to the third, just 12 divided by 4. 36 divided by 4 is 9? Okay, we got a 2 left and an x left. So the y was a perfect fourth. My answer would be 3x cubed y to the 9th. And then try not to forget the index. I always do. This is a fourth root, and left underneath you have a 2x. Okay, we're going to do one more. 64. Tell me two numbers multiply to give you 64. 8 and 8, perfect. All right, so let's see, 4 and 2, 4 and 2. And then we have, this is a big tree, 2 and 2, 2 and 2. Let me cross some stuff out. I broke down 64, 8. Let me look for a group of 4. Okay, now this one's kind of weird. So I have a group of 4 right here. I actually have 2 2s that I can't put in the group of 4. So if you have 2 numbers or 3 numbers or whatever that don't have a group of 4, when you put them back together, you multiply them together. So this, I'm going to put back together, I'm going to multiply those. So you're going to pull a 2 out in front. There would be a 4 left underneath that. 2 times 2 is 4. So if you have anything that doesn't have a group of 4, if it's different or even the same number as it is here, you put them back together with multiplication. And then x to the 20th, I'm going to leave alone because that's divisible by 4. And can I do anything with y to the third? No. If the exponent, which is 3, is smaller than the root, you can't take anything out. So I'm just going to leave that exactly how it is. The only other thing I can do here, x to the 20th, that is actually a perfect fourth root. We can pull out x to the 5th. Divide the exponent, which is 20, by the index of the root, which is 4. So the answer here, you'd have 2x to the 5th all out in front, and then fourth root 4y cubed. And like I said, a lot of these questions have really icky looking answers, but don't think you're doing something wrong because these are not going to be perfect squares and cubes. You're going to have stuff left under your radicals.